The lesson we've got going today is section 2.6, Characteristics of Quadratic Equations. And this is the last section of chapter 2. So the lesson after this will be, there really isn't a lesson. I'll be giving you a review. And that's the review you're going to want to study to do well on the test. Okay? So this is the last one. It's a little bit lengthy, but hopefully some of this you've done before. All right, so characteristics of quadratic equations. There are 3 different forms of a quadratic equation that we're going to cover today. And when an equation is in each one of these forms, we can get information easier than in others. For example, this is the vertex form. The vertex is HK. So I can find the vertex very easily, but I can't with these 2 forms. The y-intercept, I can't find it here, but I can find it here. And the x-intercepts, I can find in the intercept form. That makes sense that it would be called that. Okay, but I can't find them just looking at these 2. So when we're looking at an equation in a certain form, there are just some things we can see right away. All right, so the first thing we're going to look at is vertex form. You're going to want to write that down. And some of the things that we can find from the vertex form is, first of all, the vertex, which is HK. And remember, it's x minus h. And the vertex is HK, not negative HK. All right? And then we can find the axis of symmetry. That's x equals h. And then we can tell if a parabola opens up or down. And actually, we can tell if a parabola opens up or down with any of the forms. Okay, so the axis of symmetry is a line that divides a parabola. I've mispronounced that word so many times. I call it a parabola just to be dumb. And now I have a hard time calling it the real thing. Anyway, okay. The axis of symmetry is a line that divides a parabola into mirror images, okay, cuts it right in half, and passes through the vertex, okay? So it's just the line that cuts it right in half, okay? And the vertex is obviously on that line because it's symmetrical, okay? And there's the vertex, HK, right there. Okay, so let's look at an example. So in this problem, they want us to label the vertex and axis of symmetry. So it's in vertex form, which is nice. And if I rewrite this, this is -2 times x minus a -3 squared plus 4. So that means that my vertex is -3, 4. Okay, and if you have the vertex, you've got your axis of symmetry. Okay, your axis of symmetry, AOS, is x equals -3. So -3, 4, 1, 2, 3, 1, 2, 3, 4. Okay, there's my vertex. And now this is when I can look and see if it opens up or down. This negative out front tells me that it opens down. So if you see a negative out front, the way I remember it is somebody's negative, so they frown, okay, which means it opens down. If it's positive, people are happy and they smile, that means it opens up, okay? So just to plot a couple of points here, I think I'm going to let x equal -1, and if I plug that in, -2 times -1 plus 3 squared plus 4. This gives me -2 times 2 squared plus 4. 2 times 2 is 4, times -2 is -8 plus 4. So when x is -1, y is -4. You know, first of all though, this is my axis of symmetry. I should do that. Okay, and one of my points is -1, -4, 4. So this is what it looks like. I know it doesn't ask you to graph it, but I just wanted to show you what it looks like. And here's the vertex, -3, 4, axis of symmetry is x equals -3. So like I said, if you have the vertex, you have the axis of symmetry, it's just that line x equals your x value right here. Okay, so I want you to try this one. Oh, I guess that last one did ask you to graph it, duh. So does this one. So go ahead, and I know you may not have graph paper, do your best just to do it on a piece of paper, but go ahead and pause. All right, so again we have this in vertex form. So we've got our vertex. Our vertex is 2, 5, not -2, 5, it's 2, 5, which means our axis of symmetry is x equals 2. So 2, 5, 1, 2, 3, 4, 5. Here's our axis of symmetry. Okay, and I know that it's going to open up because it's positive out here. Okay, so it's smiley, it's gonna open up. All right, so just plugging in, I'm gonna let x equals 0, I'm gonna plug in 0. We've got 2 times, if I put 0 in here, I get -2 squared plus 5. So that's 2 times, -2 times -2 is 4, so this is 8, plus 5, oops, not 2 times 8, I'm sorry, 2 times 4, which is 8. And that gives me 13. So 0, 13 is one of my points. So I think this is 10. 11, 12, 13, which means I'll have it up here. Anyway, it's kind of up a little ways, and that should be more curvy. It's not an absolute value function. Okay, so really what we were looking for is we were looking for the vertex, the axis of symmetry, and then it looks something like that. All right, so next we have the standard form, and I will cover that in the next video.